Hey guys, I had a little request for how do you deal with the fact that manganese is a self-indicator in a permanganate titration? Well, let me tell you straight up, the permanganate ion, when it's dissolved in water, normally as potassium permanganate, ends up giving you a dark purple solution. And when you're doing a permanganate titration, the solution you fill your burette with is often going to be a dark purple, just like that marker there. The titration that I've shown you here is iron 2 being oxidized to iron 3, and the manganese is being reduced. Iron 2, I believe, is a light green color, even lighter than this, but I don't have any other color markers. So, you start off with iron 2 in solution, and permanganate is the purple. Now, add a little bit of permanganate to the beaker. So, we've decreased the amount of permanganate in the burette. I'm obviously exaggerating how much we're adding. And what you end up with is some purple inside the Erlenmeyer flask. But, remember titrations? You shake the Erlenmeyer a little bit, and then that color disappears. It's because in certain places in the solution there's still lots of permanganate, but if once you shake it, this reaction happens and you end up making some of this product. What color are these products? Well, iron 3 is like a light yellow color, and this manganese here is colorless. So, as you add permanganate to the iron 2, you end up with less and less and less permanganate in the burette, and you end up creating a yellow solution of iron 2. Now, how do you know when you've reached the end point? How do you know when you've run out of iron 2 and you've converted everything to iron 3? You'll know you've run out of this when you add this and it doesn't disappear anymore. And luckily for you, you can know when you have excess of this or when you're adding this and it's not disappearing, because all of a sudden a single drop of this permanganate will just, stain this supposedly yellow iron 3 solution the faintest color of purple. This is called a self-indicator because the chemical that's actually doing the titrating, in this case oxidizing iron 2 to iron 3, is the same chemical that's causing the color change. And the color change is how you know you're at the equivalence point for the titration. Pretty swag. Best of luck.